I'm Andreia, and I'll be presenting my research project. We were looking at trying to connect people to science using everyday objects. Just before I start talking about the project itself, I just want to read the room and see what's your connection with science. So if you feel connected with science, meaning you actively seek for news, events, activities, show me a green card. If you like science, but you don't make a special effort to keep informed, a yellow card. And if science is definitely not for you, a red card. Okay, there's a lot of yellow cards. A few green cards. We have a very scientific audience today. Well, so the UK public, in general, people understand the importance of science. So 82% recognizes science importance. However, only 22% feels actively connected to science. Why do we see this gap? So people think science is too specialized, too complex, and irrelevant to their everyday lives. So when designing a public engagement activity, we need to take in consideration three aspects. So we want our activity to be engaging. We want the participants to have fun. We want our activity to have a take-home message. So we want the participants to learn something. And finally, we want the activity to be relevant. So what if, instead of using scientific examples and weird language, we started using everyday objects like toothpaste or laundry detergents? So this is what Glowing Science is doing. Glowing Science is a public engagement project by the Hudson Group, a molecular pharmacology lab, and we develop tabletop activities to explore the concept of fluorescence. The main aim is just to raise general awareness about pharmacology and drug discovery. So what are we going to do today? So in the talk, we'll teach you some science using everyday objects. I will talk you through the experiment, how I designed it, how it works, what our data actually showed us, and why it is important. So what is fluorescence? So fluorescence is this phototypical process that molecules or objects absorb light and then emit light at a longer wavelength. This was first found in nature in jellyfish, and jellyfish have green fluorescent protein. So this protein is the most commonly used protein, fluorescent protein in research, but how do we use it? So we tag our protein of interest with a GFP, and that enables us to see things that otherwise we couldn't see. This is a microscopy image taken by a member of our lab. So, but still a very complex concept, right? So how does this relate to us on our daily lives? So if you're going to look at these two everyday objects, laundry detergent and a safety vest, which one do you think it is fluorescent? Well, keep that in mind. This is what we are doing when designing the experiment. So we selected a range of objects, half of them being everyday objects, like earrings, a safety vest, laundry detergent, toothpaste, and science objects, so things that we use on our daily research in the lab, like cells and bacterial culture. So we had all the objects lined up and on a table, and the participants were given 1 minute to sort the objects according to what they thought was fluorescent. This was just for us to understand the general understanding about the topic. After this, we provided a brief explanation. So half of our participants got a scientific explanation, where we explained that we stain our cells with fluorescent dyes to be able to see them. And the other half of the participants got an everyday example. So we explained that banknotes have safety features that are only visible under UV light, and that is fluorescence. After the explanation, the participants were given another minute to sort the objects, and hopefully now they'll get more right answers. The third round, we would give them a UV torch. This way, the participants could actively look for fluorescence in individual objects. So going back to the two examples, the object that's actually fluorescent is the laundry detergent and not the safety vest. You'll be able to see in the video. So laundry detergents have fluorescent compounds that make our t-shirts look whiter than white, or our clothes just look more colorful than they actually are. Instead, fluorescence is not present in a safety vest. It is bright, it does have reflective strips, but does not emit light at a longer wavelength. It doesn't let us see things that we wouldn't otherwise. So what did our data actually show? We didn't see an improvement in connection for the group that got the everyday example over the group that got a scientific example. However, what we saw was an improvement in understanding of the scientific concept. So as you can see, in black, we have the pre-explanation scores, and then in pink, we have the post-explanation. And the everyday group, the average of scores increased post-explanation. Interestingly, the scientific group, the average actually went down, which might suggest that if we speak science with weird languages and things that people are not familiar, it might just confuse the participants. A third finding, and we weren't looking for this, was the use of UV torch was the one that actually had statistically significance. So people actually learn more when they're actively looking for fluorescence and engage with the concept. So what did our research show us? That everyday examples are a powerful tool to explain science, especially over scientific jargon that just confuses our participants. The power of active learning, people learn better when they play, when they explore the concepts over any kind of explanation, regardless if everyday or scientific. And finally, the aim of these projects is to bridge the gap between society and science. Why do we want to bridge this gap? For me, there are three main reasons. The first one, most research is funded by public investment, so this allows us to show society that this not only benefits scientists, but society as a whole, to inspire the next generation, to make kids excited about science, and hopefully they will want to become scientists, and finally, to tackle misinformation. After the pandemic, we've understood the powerful or dangerous misinformation, and it's good for people to feel informed about science and connect about science. I just want to finish off by thanking everyone that helped me in the project, in particular Dr. Hudson, the supervisor, and everyone in the Let's Talk About X team for allowing me to present my project, and I'll be happy to take any questions.